Hi, B students. I'm just going through the exit ticket for today. The first question you have on the exit ticket is, in your own words, how do we find the equation of a tangent line? Well, I'm gonna mainly let you guys come up with your own definition for this or your own writing because, yeah. I'll say though for this explanation, it would be very important you have these terms at least written out. So first we need point slope, right? So we're gonna need slope and point. Both of these terms should be in your explanation. Also, I would say you need the word derivative because we're finding this to find the slope of a tangent line, right? Of a tangent line, you're definitely going to need to find the derivative because that is ultimately the slope of the tangent line. So I would say your explanation, whatever it is, should include these three things. Next, we're going to consider the polynomial 7x squared minus 4x cubed minus 2. Find the equation of the normal line to the function at x equals negative 2. Find the equation to the tangent line to the function at x equals negative 2. Okay, so I am going to switch up this function to, let's say, 3x squared minus 3x cubed minus 2. I'll say 4x cubed. So first, let's find the normal line. Right, this is part A. So part A, we want to find the normal line. The normal line means the line is perpendicular, right? So first, how am I going to find that? Let's first find the slope and the point, right? We're trying to use this to get point slope form. Well, the slope of the normal line is going to be the negative reciprocal of the slope of the tangent line, right? So we're going to first find the slope of the tangent line, and we're going to do this by finding the derivative. So g of x, I'm going to erase that for now because I'm going to need that space. So g of x is equal to 3x squared minus 4x cubed minus 2, just rewriting what I have up here. Right? So then g prime of x is equal to 6x minus 12x squared, right? I just did power rule there. Next, I'm going to plug in x equals negative 2, so I can get the slope of the tangent line at this point. So at x equals negative 2, it's going to be 6 times negative 2 minus 12 times negative 2 squared. So that is going to be equal to negative 12 minus 12 times 4, right? So that's going to be equal to kind of a very steep slope, but negative 12 minus 40, so it's going to be negative 60. It's negative 12 minus 48. Okay, so that's the slope of the tangent line. So the slope of the normal line, right? The slope of the normal line is going to be the negative reciprocal. So it's going to be 1 over 60 because we flip 60 from the numerator to the denominator. So now it's 1 over negative 60. And then you flip the sign. So now it's 1 over positive 60. So 1 over positive 60. So this is our slope. We found m. Found m. Now we need to find the point, right? Because that's the other component we need for point slope form. So our point is going to be, we're just going to plug in. So we have x equals negative 2, right? So that's part of the point, right? Because we know the line that's normal, it crosses at negative 2, right? At x equals negative 2. But we need to find the y. So we're going to plug in x equals negative 2 into this function. So y is going to be equal to, I'll write that over here, y is going to be equal to 3 times negative 2 squared minus 4 times negative 2 cubed minus 2, right? I just plugged in negative 2 for x. So that's going to be equal to, this is kind of messy. Let's say that's going to be equal to 3 times 4 minus 4 times negative 8 minus 2. So that's 12 plus 32 minus 2. So that's 10 plus 32 is equal to 42. Okay, so my point is going to be equal to 42 for y. Y is equal to 42. So I have negative 2 comma 42. Right, now my point slope form is y minus y1 is equal to m times x minus x1. So it's going to be y minus y1, which is 42. That's our example point. M is 1 over 60 times x minus x1. So x minus negative 2. So y minus 42 is equal to 1 over 60 times x plus 2. So this is going to be my answer for the equation of the normal line. Now the second question is sketch the normal line and tangent line on the graph of g of x shown below. Well, I use a different g of x, right? I use this one. So this is not going to be the proper function, but I'm just going to give an example. Let's say I drew a tangent line here. The tangent line would look something like this. Remember, it like is parallel to the function at that point, basically. So it just touches at this one point. And then the normal line is exactly perpendicular to the tangent line. So it's going to be probably like this. It's going to be exactly perpendicular. So those are going to be right angles. So yeah, that's the process again. Remember, you find a slope and a point, so you can use point slope form. And then you need to be careful on what the slope actually is. Is it parallel? Is it a tangent line, or is it a perpendicular normal line? And then that tells you the slope. So thanks for watching, and hopefully that helped.